it because it'll be beneath the positional units of the CAD file, or the working units. Right, so we'll measure that. There we are. It comes out as 0, so it's obviously less than a mil. I would put it at about, there'd probably be, I don't know, 50 along there. All right, so let me just make absolutely sure of one thing. Good, we are all on one plane right there. And I will undo back to there, my view. Now let's just extend. We'll extend this line string out to there. And we'll extend the other end of the line string out to there. Then I'll take this line string and draw another one, and then I'll close it. So now we have a closed shape. Why have I closed the shape? Because in a moment, the screen conks out. There we are. Because in a moment, we will be projecting this forward to create a new line string. But well, my feeling is that if this y depth is greater than just small y depth, which would result from this low point and this high point, it gives a greater certainty that the software will calculate the trajectory of the cut truly parallel with the horizon. And I feel that if this y-axis is slightly shorter, there could be some room for error. Anyway, that's just an old habit. So, right, so now let me introduce you to the billet. There's the billet. Let's go to the top here. So what's the billet? Well, let's go to a rotated view. And let's put some shading on. Let's go to smooth. So that's the billet. And it's going to help us create a lovely new line string. So we'll go back to top view. There we are. Okay, so this billet is at its ends, it has a 3-meter radius, which corresponds with the 3-meter radius of the front face, the lowest front face of our edge beam. Our edge beam starts off with a 3-meter radius at ground level, at pavement level, and then it transforms into a conical surface above that and another conical surface above that. But right now we're only interested in this. Let me just rotate this for a moment. We're only interested in this surface here. Like I say, this is a conical surface, and this is a conical surface, and this is a flat surface, and this is a flat surface. So right now we want to generate that line there, that face there, and this curve here. So back to the top view. Let me drop that. I only want to work with half a billet, right? So let's delete half the billet. And let me rotate so we just see what's going on. Okay, so now here is our new 2D profile, which retains information of the 3D profile. So in other words, we have encoded this 2D element with 3D information, much like, I suppose, like a hologram does. So now what we'll do is we will cut this solid with this cutting tool. So that's the solid we want to cut, and we want to cut it with this profile. Bang, there we are. So I cut that at approximately 300,000 kilometers per second, which is the speed of electricity. And now we will delete the top half, and we're left with the bottom half, and we will start to drop. We will drop this because there are parts that we don't need. I'm probably dropping too much. Right, so we're going to get rid of everything and leave ourselves a lovely new smooth, where it's meant to be smoothly curved, and flat and straight, where it's meant to be flat and straight. Line string. Great. Okay, so there it is. I'm just going to convert it into, it's actually segments, so we just need to convert it into a chain or a line string. Why has it gone purple? Is it a line string? Let me move it. Not yet, it's not. Let me just rotate and see if anything is out of plane. Ah, there's an extra bit there that I don't need. That might have caused some issue. I don't see why. Right, was I on automatic? Yes, I was. Okay, well, there it is. It's blue. Yeah, okay. So now we can delete this. We don't need any of that. Let's leave those gates there. Right, so all we got to do now is take our profile. Hold on, let me get these locks off. We've got to take our profile, put it on our line string, and project it, extrude it along an element, which is this newly created element. Let's lock the axis to be there. There it is. Let's have a shade. Okay, so that is almost our edge beam. We've just got to improve it a little bit. Let's put different lighting on. Good. All right, so now if we have a look here, you can see that our apogee, our zenith, is right there. It was there. That's where I placed the highest gate, and it's transferred all the way to the top. And we have successfully extruded all the way round on a lovely undulating curve, because we smoothed it out, we coded it onto this flat plane, and then we projected onto that ovular cylinder, and rather we cut through it. And cutting through the face of a cylinder, as you know, creates an arc. If you cut through the face of a cylinder on a slope, you get an elliptical arc. So so there's our almost finished edge beam. So let me go back to top view. Where's my top view? Top view. So now let's just take this. And let's put it right there. And then let's cut this shape with this profile. And let me do that again. I want to see it vanish. So we'll cut it again. Cut there, and there, and oops, wrong half. So we're going to cut this object with this profile. And there we've almost arrived at our edge beam. Let's just take this and put it there, and we will extend it a little. And let's take this one, put it there, and extend that one a little. And now we will cut it again. This time we will split the solid like that. Oops, sorry. Like that. And we will delete that. And delete that. And then we will unite these two solids. This one, we'll unite them like that. My screen went again. My screen keeps conking out. I've got a spare one, which Spar kindly let me take. So my locks are off. So let me rotate this view so you can admire your new back.